question 7, I'm only going to record myself going through the first few of these because it's quite an involved question and there's no quick way around it. You're going to have to smash it out yourself. So what we're doing is we're going to create triangles for each relevant angle. We're going to figure out the x and y, and then we're going to figure out sine, cos, and tan. Remember, sine theta is y over r, cos theta is x over r, and tan theta is y over x. And with this question, r is 4. So these are really important. So for the first one, they've asked me to do it for negative 30 degrees. So what I'm going to do is I'm going to go from the center out to negative 30 degrees, and I'm going to draw a triangle under it. So for this triangle I've just done, y equals minus 2 and x equals, I've gone along to 3.2, do you think? Yeah, no, I'd just say 3.25. So for this one, sine of negative 30 equals, here x was 3.25, y was negative 2, r is still 4, so sine is x over r, so y over r. Did I write that correctly? Yeah, y over r. So we've got negative 2 divided by 4, so negative 1/2. Cos is 3.25 divided by 4, which gives me 0.8125. Now, technically that should have come out as 0.866, but you're going to learn that next lesson. You actually learned that last year. That's root 3 divided by 2. And tan is y over x, so we've got negative 2 divided by 3.25, which gives us negative 0.62. Now let's go back and do it for 0. So this time, we're going straight across from 0. So here, x is 4, y is 0, r is always going to be 4, by the way. You can just write 4 all the way along, etc. So sine y over y over r, so we've got 0 over 4, so it's 0. Cos x over r, 4 over 4 is 1. Tan y over x, 0 over 4 is 0. Okay, now let's go to 30 degrees. So we're up here. We're going along from this one side, so that's 3.2 again. And x is 3.2, y is 2. So sine, and you're going to keep doing this for all of them, okay? Now, I'm not going to film myself doing that, but I will complete it now, and you can see the PDF of this in the OneNote. Alright, now that we've filled out that annoying table, let's graph these suckers. So this is what my table came out as. Let's graph sine of x. So sine of x, the main points, we're going to start off by marking on the main points. 0. At negative 30 it was negative 1/2. At 30 it was positive 1/2. Then we got to the 0.85, and then we got to 1. And then you'll notice it started to come down again. And it also formed the same shape all the way along. So if we give these a nice kind of curve in between, you can see that we get this kind of shape for sine. If we have a look at that, have they asked us to find the domain and range? No. Okay, now let's do the same thing for cos. Cos, though, started here. What was it at minus 30.86? So it went along like this. So you can see they both have the same shape. They do. They both have the same shape. This last one wouldn't have been here. It would have been here. They have the same shape. But it's like cos is the same thing, but it's kind of everything's moved left. Hasn't it? See, the bottom down here is here, but the bottom down here is here, and the top here is here, but the top here is there. So it's the same shape, but it's all been moved left, and technically it's been moved 90 degrees. I mean, you could have also considered that it had been moved right. Yeah, I'd say sine's cos moved right by 90, or cos's sine moved left by 90. Tan's weird, okay? Get ready for tan. So for tan, we also need lines at, oh gosh. Tan's like completely different, yeah? So for tan, we're going to need lines at 0.59 and 1.7. So 0.59 here-ish. Oh, there's one. Wait, where was one? Halfway through that, okay. So there's one. 0.59 I'm going to put here, which means 1.7 I'm going to put here, okay? So I'm going to put minus 0.59 and then minus 1.7. So let's put in tan. At minus 30, tan was minus 0.59. At 0, it was 0. At 30, 0.57, 0.59, sorry. At 60, $1.7, 90, it was undefined. Okay, at 120, all the way down the bottom again, 150, 180, 210, 240, undefined again. So for tan, we actually get this really weird shape that cuts in and out. Oh, nope. Like that. And that's how you graph sine, cos, and tan.